Assalamualaikum warahmatullahi wabarakatuh. Our next topic is elasticity. There are two definitions that you need to know. The first one is elasticity, this one, but I'm not going to write it for you. You have to listen carefully. I'm going to read it and then please jot it down in your notebook. Elasticity is defined as the ability of a material to recover its original shape and size after the force that changes its shape is removed. Okay, that is the definition for elasticity. And the definition for elastic limit: the maximum weight that can be loaded on a spring so that it just remains elastic. Okay, that is the definition for elastic limit. Now let us look at the situation here. Let's say you have a spring, and then this is the original length of the spring. Let's say this is L, and then all the springs here are identical. Let's say the spring is loaded with M load, and then it will extend something like this. So how do you know what is the extension of the spring? This length, let's say this is L1. Okay, this is L, so L is subtracted from L1, so you have extension X. Okay, I can write something like this: L1 minus L equals X. So that is the extension of the spring. And then when you load with 2m mass, means here the mass here is twice as much as this one, so you have 2x extension, and then 3m, you got here 3 times extension. So when you have the data here, you can plot a graph over here. So let's say this is x, this is 2x, and this is 3x, and this is m. Remember, this is force, so you need to apply W equals mg to know what is the force, because force equal to weight in this case. So this is F1, F2, and F3, for example. So you're going to get a straight line like this. So when you plot the graph, it's going to be something like this. Okay, from here we can try to make a relationship between force and extension. So force here refers to the stored force in the spring itself. So you can write from here, you can see that F is directly proportional to X. Okay, F is directly proportional to X. But remember, this is sign of directly proportional. How do you change this sign into equals? So how do you do that? In order to change from directly proportional sign to equal sign, you must put a constant k. F equals kx. So k here is a constant. Okay, now I wanted to compare with a linear equation. We have y equals mx. So in this case, you can see the graph starts from 0, so this one should plus 0. Sorry, plus 0. So in this case, there's no y-intercept, or there's nothing here, so you can ignore this one. And then f is y in the y-axis, and x is in x-axis. So this is x. So from here you can see here that the gradient of the graph is actually the constant, is the spring constant. Okay, this is something that you need to know. And then what about the unit for gradient? So from here, gradient, you can calculate the gradient using the formula, but can write f equal to kx. So k equals to f over x, and the unit for f is Newton, and the unit for x is centimeter. It depends whether you are using centimeter or meter. So yeah, the unit for k is Newton centimeter, -1. And this is actually known as Hooke's law, and you can watch the next video to know what is the definition for Hooke's law. Or I can read it for you here. Hooke's law states that if a spring is not stretched beyond its elastic limit, the force that acts on it is directly proportional to the extension of the spring. Remember, if you apply too much load, then the structure of the atom in the spring itself will be damaged, so it will not return to its original length anymore. So the graph will be something like this. Okay, so this is elastic limit. Actually, you need to carry out the experiment in order to get the actual data.